Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Acid, Bases and Salts. This is a very important topic. You get a lot of questions from this, and there are a few formula that you have to by heart. That's the name of certain salts and their preparation, their formula and also their uses. So let's begin. What are salts? Salts are basically ionic compounds. Ionic means what? Charged particles, right? So a salt has got two parts. A positively charged part or the cation and a negatively charged part called a anion. So these two together form a compound called a salt. So salt can be of different types depending upon the types of acid or base involved in it. Salts of hydrochloric acid are called chlorides. Salts of sulfuric acid are called sulfates. Salts of carbonic acid are called carbonates. Salts of nitric acids are called nitrates. In other way, if you say, there are different types of salts depending upon their nature. Suppose we are combining a strong acid like sulfuric acid or hydrochloric acid or nitric acid with a strong base like sodium hydroxide or potassium hydroxide, we get a neutral salt. Because acid is also very strong, base is also very strong. When they come together, it becomes neutral. Both neutralize their effects. Whereas in the second case, acid is very strong but base is little weak. So when they combine, who is having an upper hand? Acid is having an upper hand. So the salt will be acidic in nature. For example, if you take hydrochloric acid, which is very strong, and you take ammonium hydroxide, which is a weak base. So the salt we are getting is ammonium chloride, which is an acidic salt. Now the next is a weak acid. Acid is little low, base is little high. So when they combine, who is having the upper hand? Base. So the salt will be basic in nature. For example, a weak acid like a carbonic acid, if you combine it with a strong base called sodium hydroxide, we get a salt called sodium carbonate. So sodium carbonate is what kind of salt? It is a basic salt. Which all ways do we get salts? So when we were learning the chemical properties of acids and bases, we found that first the acids react with the base to form salt and water. Apart from that, acids react with the metals to form salt plus hydrogen gas. Bases also react with the metal to form salt plus hydrogen gas. Acids react with the metal carbonates or metal bicarbonates also give salt plus water plus carbon dioxide. So in all these cases, we are getting salt. So neutralization reaction is normally used for preparing salt in the lab. We can take hydrochloric acid, and if you take sodium hydroxide, what will you get? Sodium chloride and water. So sodium chloride is a common salt that we are using in the lab, and since it is made up of two strong components, strong acid and strong base, what kind of salt it is? It is neutral. So we are using it in our common purposes, that is in the kitchen also, like a common curry salt, what we are telling, or the table salt is nothing but sodium chloride. So all of you have seen sodium chloride because it is there in our kitchen. But originally, are we preparing it in the lab for a huge amount, because every household needs this salt, right? And we have got lot of other uses also with the salt. So in that case, how can we prepare the salt? It is usually obtained from the seawater. So seawater is evaporated. As a result, we get the salt, and the salt is later purified for our use. Sometimes we get salts as rocks also. That is, in bygone ages, when some seas evaporated and the salt got deposited as the bed of rocks. So in such cases, we are mining it out or cutting it out from that bed of rocks, and it is in the solid form. Usually it is brown in color due to impurities. Common salt has got lots of uses in our daily life. It is used in curries, you know that, to add the flavor. Second thing, it is used as preservative in dry fish or dry vegetables, pickles, all these we are using salt. Salt is also used in the preparation of various other compounds, like for the preparation of the baking soda, preparation of baking powder, because baking soda is used for baking powder. It is also used for the preparation of washing soda, and also it is used for the preparation of caustic soda or sodium hydroxide. So all these other compounds also we are getting from the common salt. Now let us see how do we get sodium hydroxide or caustic soda from our common salt. Let's see the preparation of sodium hydroxide using common salt or table salt. So sodium chloride is actually now mixed with the water, that is aqueous solution of sodium chloride, that is called a brine. So brine is nothing but you are adding salt to some water, salt water, that's it. Okay, so to the salt water, if you pass electricity, it will start ionizing. So during that time, what happens to the sodium chloride? Sodium chloride will dissociate to form sodium cations and chloride anions. At the same time, water will dissociate to form H plus cations and OH minus anions. Now what will happen to these ions? So chloride is actually an anion which is having negative charge. So it will move towards the positively charged anode. Okay, so chlorine will go to positively charged anode. There chlorine will lose its electron. It has got one electron. It will lose its electron and become chlorine. Two chlorine atoms combine to form chlorine molecule. At the same time, H plus is a cation. So it will move towards cathode, which is negatively charged. So here what happens? It has a plus charge, that means it is lacking one electron. So it will absorb one electron and it will become H. H and H will form hydrogen gas. So at the anode, what are we getting? Chlorine gas will be released out. At the cathode, what will come out? Hydrogen will be coming out. Now what is left in the water? This hydrogen ions over and chloride is also over. Now these two are there, sodium ions and OH minus ions. They both combine to form the third compound called sodium hydroxide. So when we are passing electricity through the salt water, what are we getting? Sodium hydroxide or caustic soda, chlorine and hydrogen. Chlorine we are obtaining at the anode and hydrogen at the cathode. This is very important. You may get a question, where do you get hydrogen, where do you get chlorine, all. So in this case, since we are getting alkali, sodium hydroxide is an alkali. You know what is alkali? So water soluble bases are called alkali. So here we are getting alkali along with the chlorine. So this process is otherwise called a chlor-alkali process. So you may get a question about what is chlor-alkali process. Chlor-alkali process is nothing but electrolysis of salt solution, which is called a brine. What are the products we are obtaining? Sodium hydroxide, chlorine, hydrogen. What are the, where are we obtaining them? Chlorine at the anode and hydrogen at the cathode. So now we will see the uses of each product that we are obtaining after chlor-alkali process. First is sodium hydroxide. We are using it for paper manufacturing, soap and detergent manufacturing, degreasing the metals and making artificial fibers. Whereas chlorine is usually used as a disinfectant. It is used in water treatment. It is used in the swimming pools to clean the water. It's used in the preparation of PVC, polyvinyl chloride or plastic. Used as disinfectant in the formation of CFC. CFC is chlorofluorocarbon, which is actually contributing to global warming. And also we use it for making pesticides. And hydrogen is used as a fuel. It is also used for the preparation of margarine, which is actually the vegetable ghee or vanaspati, dalda we say. It helps in the manufacturing of ammonia used as a fertilizer. Salt as such is very useful for us, but from the salt we get another 3 compounds. Those 3 compounds also have got several uses. Now we are going to see how can we make other useful compounds using these products or salt. So when we saw chlor-alkali process, we saw the chlorine is forming there, right? That chlorine can be again utilized for making another very important compound called a bleaching powder. So formula of each one is very important. Bleaching powder is calcium oxygen chloride or CaOCl2. Now let us see how can we make it. We are taking calcium hydroxide, which is otherwise called a slaked lime. We came across it so many times. This time we are taking dry calcium hydroxide or dry slaked lime, and to that we are passing chlorine gas. From where are we getting chlorine gas? From chlor-alkali process. So that chlorine gas we are getting at the anode can be passed through dry slaked lime. So we will get a product calcium oxygen chloride or bleaching powder and water as a byproduct. So this is a very important compound having several uses. The main uses of bleaching powder are, it is used in bleaching cotton and linen in textile industry, so to make it white fibers, and also for paper industry. Originally wood pulp may not give you white paper, so in order to get white paper you have to use bleaching powder. The laundry bleaching powder is used for bleaching the dress, so white dress, so that we get pure white cleanliness. And also it is used as an oxidizing agent in many industries. And it is also used for killing germs in our drinking water. So this is the bleaching powder. We learned the formula of bleaching powder, how the formation of bleaching powder is happening, and what are the uses of bleaching powder. Next important compound that we have to study is baking soda. So from the word itself, it is used for baking purposes, right? So baking soda formula is sodium hydrogen carbonate. Sodium NaH hydrogen, carbonate is CO3. NaHCO3 is the formula of baking soda. Okay, so usually we are using baking soda. A pinch of baking soda will be added to make crispy pakoras, and also to soften the certain preparations like appam, and also we add a pinch of salt, baking soda, for making the cooking also easier, especially when we are boiling chana and all. If you put a pinch of this, it will make the cooking faster, and the chana will become very soft also. So apart from that, there are many uses also. How are we preparing this baking soda? So for the preparation of baking soda, the main ingredient is again our salt. So salt is our hero today, sodium chloride. To that sodium chloride, we add water, carbon dioxide and ammonia. Because we know that we have to get sodium hydrogen carbonate. So there should be a sodium source, hydrogen source and carbonate source, right? So sodium we get from sodium chloride. Then hydrogen we can get from water. Apart from water, from ammonia also. Then carbon dioxide. When you mix this, we get sodium hydrogen carbonate or baking soda. One more product we get, that is ammonium chloride. Now, when we are cooking it, usually when we are using it for cooking purpose, what happens is, while heating, it will become Na2CO3 plus H2O plus CO2. So what happens is, this Na2CO3 being basic, it has got, it's mild base, so it has got some kind of bitter taste. So our cake and bread and all, if we simply add baking soda, it will have some soapy or bitter taste. So to avoid that, instead of baking soda, we use baking powder. So baking soda and baking powder are slightly different. Remember, baking soda is a white powder, baking powder is also white, but baking soda after cooking will produce sodium carbonate, which will produce a bitter taste. So to avoid that, we are using baking powder. So how is baking powder made? With a slight change in baking soda, we can change it into baking powder. That is, we have to take baking soda, to that we add H+. H plus means what? Giving acidic property. So who will be the source for this? We have to add any acid. But can we add hydrochloric acid or nitric acid to our preparation? No. We are taking some edible acid. Edible acid means what? All the mild acids we studied, organic acids. So preferably we use tartaric acid or citric acid, like that. So usually tartaric acid is used, and once they don't react until we heat it or mix it with the water. So during that time, these two will react, and as a result, what happens? From this carbonate, large amount of carbon dioxide will be released out, which is giving that fluffy nature to that cake or the bread and makes it very soft. And next is water will also go out. Along with that, sodium salt of acid will form. That is, sodium is here, and it will react with the whatever acid we are taking. Depending upon the acid we are taking, the salt will change, but it will be a sodium salt. So clearly understand. First, sodium hydrogen carbonate is called a baking soda. But when we are cooking baking soda, from that water will evaporate, and as a result, what will happen? So sodium hydrogen carbonate will become sodium carbonate, which will give a bitter taste. So to avoid that, we convert it into baking powder. How? By adding a mild edible acid like a tartaric acid to it. So when this is mixed together, the H plus ions from the acid will replace the loss of this hydrogen from this. As a result, we get carbon dioxide, which will make the cake fluffy, and water and sodium salt of acid. Suppose if you are forgetting to add this as baking powder to your preparation like cake or bread and all, what happens? You will not see it rising up, and also it will be very hard. So we have to add the baking powder, which is a source of carbon dioxide. Another use of this washing soda, it is a mild antacid. We learned already, when there is acidity, we can use milk of magnesia, or we can also use a solution of this baking soda to pacify that. Another use of baking soda is it in the soda acid fire extinguishers. In between, inside that there is a strong acids like sulfuric acid in a can, and also surrounded by this baking soda. Once we are opening the nozzle, they will react and large amount of carbon dioxide will come out. This carbon dioxide will be forming a blanket over the fire, preventing oxygen so that combustion is not supported. As a result, we can extinguish fire. So clear? Baking soda is NaHCO3. It is prepared by sodium chloride plus water plus carbon dioxide plus ammonia. We get baking soda and ammonium chloride. Then the baking soda, if we add mild edible acid like tartaric acid, we get baking powder. Baking powder on heating will produce sodium salt of that acid and carbon dioxide and water. This carbon dioxide will make the dish or the cake fluffy. So the next compound that we are going to study is washing soda or sodium carbonate .10H2O. So here it is Na2CO3. It is also indirectly we are getting from table salt only. We know sodium chloride, from sodium chloride how we can make baking soda, right? While cooking, when we heat baking soda, this baking soda is getting transformed into sodium carbonate, which gives a bitter taste, we learned. This sodium carbonate, if you add little water to it, then it will become Na2CO3 .10H2O, that is called a washing soda. It is used in the manufacturing of glass, soap and paper. It is also used for making borax. It can be used for removing permanent hardness of water. Some water have some hardness due to some ions. About this we will learn in the 4th chapter. It is also used as a cleaning agent for domestic purposes. As the name indicates, in olden days they used to use this washing soda for cleaning the clothes. The laundry, right? So, washing soda is Na2CO3 .10H2O. So this is the first time we are seeing some formula like there is a dot coming and some molecule of water is coming. What does this mean? It means this sodium carbonate has got 10 molecules of water associated with it to make it washing soda. So without this 10 molecules of water, this is not having that the properties. Okay, so but can I add 8 or 12 or 11 molecules of water? No, this is a fixed number. So this is known as water of crystallization. That means some compounds, whenever they are having a crystal form, it needs water molecule. So we call it as hydrated crystals. Once this water evaporates, they will lose their crystalline nature. Another example is copper sulfate. We know copper sulfate is a blue color crystal. It also has got 5 molecules of water associated with it, that is giving it that blue color crystal form. But once you heat, you can see it will lose its color because that water is going, that property is changing. Again, if you sprinkle water, it will become copper sulfate crystal. So here, what is the fixed number of molecules in copper sulfate? 5 molecules. We cannot have 4 or 6 or 10, nothing. Only 5 with the copper sulfate. The same way, another important compound is calcium sulfate. Calcium sulfate has got 2 molecules of water associated with it, and this one is called a gypsum. So gypsum, when you are heating at a 373 Kelvin, means 100 degrees Celsius, it will turn into a substance with a half molecules of water. That is called a calcium sulfate hemihydrate. Hemi means what? Half. Only half molecules of water is there, and that compound is otherwise called a plaster of Paris or POP. What is the use of plaster of Paris? It is a white color powder. It can be mixed with the water and we can form different molds and cast. For example, when people are getting fracture, the doctors are using plaster of Paris to make that plaster covering for that fractured bone. The same way it is used for making so many statues, monuments, and also for decoration on the ceilings and all. It is a white color powder, but once it is hydrated with the water, it will set into a solid, then it is called a gypsum. So what is the reaction happening? CaSO4, hemihydrate, half H2O, plaster of Paris, then reacts with the again 1.5 molecules of water, we will get CaSO4.2 H2O gypsum, which is a hard substance. Hope you understood all the points that we learned today. We learned about what are salts, the types of salts, and we also learned chlor-alkali process, what are the products, then using the products, what all things we are making. Using chlorine, we are making bleaching powder. Using sodium chloride, we are making baking soda. Using baking soda, we can make baking powder. Also by using baking soda, we can make a washing soda, and also other compounds like a gypsum and also a plaster of Paris we learned. If you enjoy my videos, please keep watching the videos and like, share and subscribe to my channel Biology My Passion.